All right. Good morning, good evening, good afternoon, everyone. Thank you so much for joining today's Tridium Talk on tagging in Niagara. Today's session, we'll be reviewing some tips, tricks, and best practices associated with using tags in Niagara. We couldn't be more excited to have a couple MVPs on the call today with me as well. I'm pleased to have Kevin Mamajek and Eric Anderson on the call, who will be supporting me and covering some of these tips, tricks, and best practices. And I couldn't be more thankful to have them on the call because these are the right folks that you're going to want to get this information from.
We
They're really
allowed
going
to
to help
take shots at you at the peanut gallery?
Kevin, you can always do that. That's some of the benefits that we have of getting you guys on the call to get that a little more flavor to the mix, right? We got a great recipe in the mix here. And as such, let's get started. So before we get moving any further, a couple ground rules to cover. As always, with our Tridium Talks, we love it when you ask us questions, and we love being able to provide answers. And as such, we'll try to get those in a timely manner, but in the event that we are unable to do so, we will certainly respond to each of those questions offline, and we'll post it accordingly on Trinium.com. So without further ado, let's jump in. So before we jump into the tips, tricks, and best practices, I just wanted to give a friendly announcement to inform the community that Niagara 4.10 is almost available. We are extremely excited to release this version as it represents really a hallmark for the product due to a number of reasons. And with every release of Niagara, we can assure you that we are deriving value into the core tenets of Niagara. Those are visualization, deployment, security, connectivity, certification, and compliance. And as you can see on the screen, we've got a number of features that are really going to help you and our customers with controlling their systems, getting off a job quicker. In addition, just driving value into the products and applications that are resident on the Niagara framework. So let's cover why you should use tags in your Niagara stations, because I think that's an important thing to note before we talk about why it's important to use tags. Let's cover it from a user persona basis, because I think this will help convey the message. So from an energy manager or a facility engineer, why would I want to use tags? Because ultimately it is going to save you valuable time and resources when you're doing your job. Because what you're going to be able to do, if you have tags applied to your station components, it's going to enable you to be able to rapidly analyze large quantities of disparate systems and equipment data. And when you're dealing with a large portfolio of buildings, it's increasingly essential that you have that ability, because you're probably juggling multiple balls. You have multiple items that are on your to-do list. And the more time that you have to spend digging through data just to understand how equipment is operating, how systems are interacting together, you can really cut that time down by tagging. It helps bring it all together, especially when you're thinking about your building as a whole and your operations. Tagging is really going to improve that. It's going to give you that essential insight into your building systems and equipment operation that you otherwise wouldn't have, especially when you're using complicated point naming schemas. So there's multiple value props here for our energy manager or facility engineer personas. And certainly that rolls up into building owners. This is going to affect it's going to improve the process of the building management. And that's going to roll up to greater efficiencies for the organization at large. So from a system integrator or an engineering technician persona, if you adopt tags in your station, you really are positioning yourself to win more project bids and customers, because you can show that you've done it. You've implemented successfully. You've been able to convey the value props to the end user. And then also, when you think about just meeting project specifications just to win these bids, if you have previous success with it, you're really going to be able to deploy those in a much more efficient manner going forward. And when you think about the emergence of Division 25 and the prospective hash rate standard 223p, these things are going to be become required at some point. And in some jobs they are. So it's never been more essential that we embrace tags and try to deploy them as much as possible. And then also, from a system integrator engineering technician standpoint, you will be saving valuable time and resources while you're doing your job. Because again, it's going to eliminate those inherent issues associated with dealing with bespoke point naming schemas, because you can just use tags to search components within your station and to understand what those components are doing. So let's take a look at some of the tagging features that have been introduced since Niagara 4.0. So in 2015, Niagara 4 was introduced, and we were proud to announce the Niagara Entity Query Language, which is the mechanism that we use to search for tags within a Niagara station. Now we introduced hierarchies as well, and its use with tags is absolutely essential to its operation. And really, it's an important thing in enabling that indelible end user experience as they navigate through their systems. So there's been a number of features that we've been adding since Niagara 4.0 that's really made tagging much easier to comprehend, to deploy, and to use. And with Niagara 4.10 coming out, we have the HTML5 tag manager, some new implied tag additions. And then when you wrap it all up with the tag-based visualizations introduced in 4.9, we have a pretty comprehensive offering to help you and our customers tag their stations. But what we're here to discuss is how to do that, and what are some of the tips, tricks, and best practices for doing so. And with that being said, I am pleased to have the honor to introduce Eric Anderson. And Eric Anderson is going to jump into, how you can configure your tag dictionaries such that you can redeploy them and reuse them as much as possible. Because that's going to be essential to really your adoption of tags and to being efficient with them. So without further ado, Eric, can you discuss some observations, some tips, tricks, best practices associated with using tag dictionaries in Niagara?
Sure, yeah. And I have these sprinkled through presentation. I wanted to start, thank you very much, Stephen, for that introduction. Tagging's been a great story in Niagara since 4.0, and continue to work to make it easier to apply tags and to use them. I wanted to start though with some of the basics. Tag dictionary, kind of at a basic level, has your tag group relation definitions. Those show up in the workbench. Edit tags dialog, the new UX tag manager, the relation drop down when you're adding relations. Wanted to make a quick note about tag groups, direct tag groups. There's some confusion about these, so wanted to clear that up here. Essentially, they are a relation, an end tag group relation from a component to a tag group definition in a dictionary. I've highlighted in red the tag group's tags. Those become implied on the component that has this tag group relation. And in addition to the tag group's tags, we also imply a tag group ID marker tag. That's highlighted here in green. In this case, it's HS airflow standby set point. That is the marker tag. And that marker tag can be useful if you're looking for components in the station that have the tag group, not just components that have all of those implied tags. Word of caution, if you delete that tag group definition or its dictionary, the relation will also be deleted, meaning those tag groups tags will no longer be implied. So be careful. Our recommendation, make your tag dictionary changes in place. If you replace the tag group definition, if you replace the dictionary, those relations will be gone. So word of caution, please be careful. So smart tag dictionaries, in addition to defining tags, tag groups, and relations for direct purposes, also smart tag dictionaries include tag rules for implying those things. Why would you want to use tag rules? First, they can save on the size of your station. They can save heap memory because the direct tags require a slot. And so every tag is a slot. And so that can really add up if you're applying tags throughout your station. Also, having them centralized and the tag dictionaries under these rules can make them easier to maintain, easier to update. Once you have a good working set of tag rules, you can drop them into other stations and tags will start to be implied immediately. Trade-off with tag rules, they do they do need to be computed at runtime. That's not to scare anybody away from them. We have worked very hard to optimize that computation to only evaluate the tag rules that are necessary and not all of them. But it's just it is a trade-off. Direct tags are faster for searching, but we think implied tags are the way to go just from a maintainability standpoint. Also available, in addition to normal tag rules, we have scope tag rules where you can specify one or more components, and the tag rule will then only apply to descendants of those components. And those are available on the tag dictionary palette. Tag rules are made up of tag rule conditions. We have simple ones like and or. These are short circuiting conditions. So an and condition will stop evaluating its conditions, its child conditions, when the first condition returns false. The or condition will stop evaluating once it finds the first condition that returns true. There's the always condition. These conditions are useful if you want to apply a tag or something to everything in the station, regardless of that component's type or any tags on that component. So if it will work, it's a very efficient condition to use. The is type condition checks to see that the component is the specified type or one of its subclasses. And then there's kind of a whole class of conditions around Boolean filter. The basic Boolean filter applies an equal query to each component. If the query is true, then that condition applies. The Boolean filter has two subclasses. Has ancestor, will take that equal query and evaluate it on the component itself, and then all of its ancestors. And as soon as it finds one ancestor that satisfies the query, then that condition returns true. Has relation is very similar. It will evaluate the query on the component itself, and then any component it can reach using a specified relation ID. Some recommendations. Because they're quick, we recommend putting is type conditions first. So in the case of an and, if the type of the component doesn't match, nothing else will be evaluated. In the case of an or, if it does match, then nothing else needs to be evaluated. So they're very quick. We recommend placing them at the top. Is type will match the specified condition and subclasses. If you need an exact type match, you can use a Boolean filter, and the equal query would use the end type tags. You could say like end type equals numeric, control numeric point if you want just numeric points and not numeric writables. When using the like operator, the like operator compares a string value to a regex expression. You can make that regex case insensitive, make it ignore case by including these characters at the beginning, the parentheses, question mark I, little lowercase I. Thank you, Kevin, for that tip. That's something I've been looking for a while. Here's an example of a tag rule. This tag rule has at the top an and condition with two child conditions underneath it. The first is the is type, so it's looking for numeric writables. If it finds a numeric writable, then it will evaluate the OR condition. The OR has two Boolean filters, one comparing the end name tag or looking for end name tags that are like room CO2 or CO2 sensor. If either of those filters apply to a component, then the implied tags in that tag list, air, sensor, and CO2, will be implied on the component. There are two flavors of implied tags. There are simple implied tags where the implied value is fixed. So marker tags in the tag list, simple marker tags, or the value tag where the value is specified. Some examples, HS phase, if it's in the rule, if it's set to BC, when that tag is implied, it will always have the string value BC. HS stage equal to 1 will always have the value of 1. The other flavor of implied tags are smart implied tags, and kind of three ways these are implied. One, the implied value of the tag is derived from something. So like the end name tag, the value of that tag comes from the name of the component. And type, the value of the end type tag is the type spec of the component. In the haystack dictionary, the kind tag is set to a value based on the point that it's implied on. Other tags may or may not be implied. Other smart implied tags may or may not be implied based on something about the component. So you've already evaluated the rule conditions. The smart implied tag may have additional criteria that it will evaluate. For example, the input tag will be implied on non-writable points, and the output tag will be implied on writable points. And new for 410, we have a implied tag has PX view. That will be implied if the component has a PX view associated with it. Some smart implied tags kind of use a combination of those strategies. The unhistory tag, for example, will be implied if a component has an enabled history extension. If it does, then the value of the unhistory tag will be the ID of that history extension. In the haystack dictionary, the enum tag will be implied on Boolean points and then enum points. For Boolean points, it'll be either true, false, or if a true text or false text facet is present, the enum tag value will be set using those facet values. Same with max and min val. Those are based on the max and min facets of the component, and the unit based on the unit's facet of the component. There's another smart implied tag called the scope tag, which I will describe next. The simplest use case, the scope tag will be implied if that component has an ancestor with a tag with the same ID. And the value of that implied tag will match the ancestor's tag value. Scope tag also has some advanced options. You can search for a different tag ID rather than matching the scoped ID, the scope tag ID. You can specify an out of scope tag ID. If that ID, if a tag with that ID is found, then the scope tag will not be implied. And then you can copy the value of a different tag than the one you're searching for. Here's a simple example. The idea of this scope tag is scoped. It's in a dictionary with the namespace my. So when I apply the my scoped tag to a component named ancestor, all of its descendants will have the my scope tag implied on them. The implied tags are marker tags because the my scope tag applied to this ancestor component is also a marker tag. As an advanced example, instead of searching for the scope tag with the scoped ID, I'm going to be searching for other. I have specified an out of scope ID, and instead of copying the tag I'm searching for, I'm going to copy the value of the n name tag on that ancestor. So here I'm applying my other tag to the ancestor component. Because folder 1 has the my out of scope tag on it, the my scope tag is not implied on it or any of its descendants. Folder 2 does have the my scope tag implied on it, and all of its descendants also have it. And the value of those tags is copied from the value of the n name tag, which in this case is the string ancestor. In a station, one reason you might use a scope tag is for system indexing. So under the tag dictionary palette, there is a system index dictionary you can drag into your tag dictionary service. And it adds 2 tags, an excluded and included marker tag. And it also, the tag dictionary includes a tag rule that implies an excluded scope tag. So if you want to exclude a certain section of your component tree, you can apply the excluded marker tag to the top of that part of the tree, and then the excluded tag will be implied on all of its descendants, and the system index will ignore those components when indexing. If you want to include a subtree of the tree you're excluding, you can put the marker, the included marker tag on that. Because that's the out of scope tag, then that part of the tree will not get the excluded scope tag. In addition to smart implied tags, we also have smart implied relations. The Niagara dictionary has the end child and end parent to use relations to traverse the component tree. If you're on the driver network, you can use the end child device to get all of the child devices under that network. And if you are at one of those devices, you can get up to your network by traversing the end parent network relation. On a device, you can use the child point and child null proxy point relations to get from the device to all the child points. And then the parent device can get you back from the point to its device it belongs to. In the Haystack dictionary, we introduced in 4.6 the equip ref and site ref relations. These smart relations will be implied between any non-null proxy points and an ancestor that has the HS equip tag on it. If that equip component also has a site ref relation to a site component, the site ref relation will imply a relation from those non-null proxy points to that equips site. So save you some time having to add a lot of extra direct relations. So those are all the features in Niagara that we have to support tagging to make it easy to use and easy to maintain. Tag-based PX graphics is one of the features that uses all of the tag and relation information in your station. Tag-based PX graphics were introduced in 4.9. They use bindings based on equal queries. So the bound components, they have to have the expected tags and relations, but they don't have to have the same name, or they don't need to be located at the same place in the component tree. We can find them, we'll find them just based on tags and relations. Traverse queries, equal traverse queries can be used to bind, to create bindings and to anywhere in the station using relations. So if you wanted to bind to the site of that point, you could do that with a relation. It doesn't need to be under or in a specific location relative to where the graphic is. And the whole point to tag-based PX graphics is to make them more reusable between stations. And I'll show an example of that in a minute. Another feature in Niagara that uses tag and relation information is system database. Along with system database is the system index, which periodically updates the tag and relation information for selected entities from each station in your Niagara network. By default, will index all networks, devices, points, schedules, point device folders. And now in 4.10, we'll also pull up any components with a PX view using the new N has PXView tag, implied tag. System database is single tier only for now, and it enhances any features that use NiCO queries. So search, hierarchies, you can search all of the stations in your Niagara network, make hierarchies against them, as long as they've been indexed up to your system database. And then new in 4.10, we now support virtual tag-based PX graphics. So if your supervisor has a SystemDB and you've indexed your stations to it, you can leverage for virtual PX graphics against them, tag-based PX graphics against that system database, and I'll show that in just a second. So I'm going to jump out of the PowerPoint, go to a station. I have a simulated JACE here with a folder that represents an AHU. All of the points for that AHU are directly underneath the folder. And I've copied this graphic, which is full of slot path ords, to here, and I'm going to edit this graphic. In the bound ords side panel, there's this little tag icon, which brings up the Equalize ords dialog. The Equalized ords dialog is there to assist you in converting your slot-based ords to ords that have NiCO queries in them. That's what's been done here. I click OK. All of my bound ords are converted. The graphic, as it is here, continues to work, but the bindings are being resolved using NiCO queries now instead of slot ords. The advantage there is I can take this PX graphic and paste it into a different station. In this station, the AHU, instead of all of its points being directly underneath that folder, this AHU is being visualized or modeled as a device folder with two stations, and the points for that AHU are divided between these two stations. So they're not directly underneath, they're different stations and the point folders of those stations. But because those points have been tagged, I can take that tag-based PX graphic and reuse it here. And the NiCO queries resolve, everything, all the components get bound in the graphic, and it's good to go. Last thing I wanted to show real quick, up at a building supervisor, this building supervisor has a system database service installed on it. Under that system database service is a system index service. I'm going to execute the Niagara network indexer. It's gone out and indexed the stations in my Niagara network. And now I can go to the Niagara network. I'll show this real quick. Under the virtual policies, I've enabled importing virtual PX files on demand, and then enabled virtuals on my stations. Going into the virtual space, I can click on this AHU. This graphic is the slot-based graphic. I'm going to switch to the tag-based. That's been imported, and now these NiCO queries are being resolved against the system database on the supervisor, but all of the bindings are working and the graphic has been pulled up seamlessly. I can go to the other supervisor, into its virtual space, Niagara network, go back to that device folder. It's imported the tag-based graphic. It is, as with the other graphic, it's also now resolving those NiCO queries against the system database.
It's fantastic, Eric.
That's all I have to show. Thank you.
This is absolutely fantastic. I think you've done a great job at conveying, how effective tags are, and not only saving you time, but helping you understand your building systems data, and really forming an indelible end user experience for our customers too. So this is absolutely great. This is a perfect segue because you covered the system database, you covered some of the reusability that we capture here with our tag-based graphics. And now we can talk about how tags enable analytics. And for that effort, we've got Kevin Mamajek, who is our local expert. And Kevin, can you share some of your thoughts and some of your just tips on just an overview on how analytics uses tags?
Sure. And I'm going to actually add to that on what else I can use tags, because I'm a hierarchy newbie. You guys have the Jedi Masters. I'm yet a Padawan, so I'm going to show you some tips that I use to kind of work through my stations. And I do hierarchies probably every 6 months, and then I go, oh, how do I create those again? So what I've done here is I'll show you how I use tags to do that. I'll show you some benefits of the tagging in searches as well. But analytics is all about tags. I can't overemphasize that. We've got lots of videos up there that talk about how to tag and utilize the tags in our analytics service. So what I want to point out here is Niagara's tag dictionary service is actually very powerful. And I didn't understand this until I started to see how certain customers would look at certain types of tagging services and things of that nature. What you can do is you could build a tag dictionary that actually applies other tag dictionaries tags. And why that's important is when you start to create your rules, you'll probably want to follow certain standards like haystack, right? So I don't necessarily have to worry about adding things to the haystack dictionary. What I want to do is I want to worry about making sure a rule that I create applies those tags. And what's nice about that is you kind of future-proof when you do that. So what I want to do here is kind of walk through some things that we can do within the analytics service or the tagging service to create some best practices for analytic tags and so forth. So what I'll do is we'll kind of take a look at how I built out my building, right? So I have a building, right? And then I have a layer that I've added called building logic. I've kind of learned this through, hard knocks, right? I try to figure out how to best optimize this so I can copy and paste into other stations as I'm working on things. So what I've learned is that, first of all, you want to tag by rules. And then I like Eric's phrase of short circuiting. I usually say fail fast. I think I like short circuiting, right? When you start to imply your tags, you want to make sure that it doesn't search the entire station. So that is type is nice because you can say, hey, it has to be a driver. In my case, I'm using control points or folders and things of that nature because I don't have them in the driver level, but those are all good. So where I'm going with this, with my best practice here is I've got several analytic proxy points. And if you've watched any of my videos, I'm all over analytic proxy points because not only do they help me test, but they allow me to get smart alarms and smarter dashboards because I can get these results no matter where they are in the station by where they live. And so where I want to kind of show you this tips and tricks is my building logic layer. I actually relativize the node, right? So, and watch the analytic videos, right? There's a, where do I look, what I'm looking for, and then I can tell it what type of range I want. Was it yesterday, a year ago, right? All those are in there, but this is looking for these two tags. It has to have the temp sensor tag and it has to have the haystack sensor tag. So I'm refining that a little bit more, but why I want to show you this relativization is going to make this building logic layer very easy for me to cut, copy, and paste all of these analytic points that are inside of it to other places and not worry about them. If you've done relative nodes, why I have one extra one is you have to remember that my maximum temp here has a proxy, and then I'm inside the proxy. So I have to go up yet one more level in order to get to the building. And so if we look at how this this works is that I essentially have all of my analytic proxy points relativized, which always point up to the level above it. Okay. So if I have a analytic proxy point inside the building logic, it will go up and run against the building. If I have it in a floor, it will go up and run against the floor. And so if you look at the way I've laid out my building and you look at these proxy points, these are exactly the same here as they are down here in the floor. So I know that when I look at them at this level, I get the building's maximum temperature or maximum humidity or average humidity. If I look at them at a floor level, I'm getting the floor's average, right? And so this is kind of a best practice that I've done. The other best practice is I use these proxy points, these analytic proxy points over and over, and they don't count against you, and they are in the analytic palette. So this is a way I can get an answer for an analytic directly onto a wire sheet so that I can take advantage of it, right? So this is very important. Again, hard knocks. The other thing that I've done is when I do, I start to build out my custom dashboards. I will put in a button to remind myself to refresh the cache. One of the things that happens with Niagara is when it first starts up, it will delay the cache for the analytic engine, which grabs all those tags and makes it into a nice little cache so that the analytics can run super fast. So you have to remember that if I go in and I duplicate a room and it has additional implied tags or direct tags, they're not in the cache. So I can hit the poll, which is my trigger, and you'll see that it actually executes. So I always start out as a trigger poller to kind of work through this. I have a button that goes to the polling page so I can understand how it's executing. Again, I've learned this kind of hard knocks because when I forget about pollers, I end up doing some things that might be not advantageous to large production systems, right? So for instance, if you look at this quick motion poller, it polls for 30 seconds. If you give it a rate, it will always try to complete in that rate, which means it's going to take that 30 seconds and move through those 42 queries evenly. So if I have a, let's say 6-minute poll and I have 2 things in it, it will pull the first item, it will wait 3 minutes, and then it will pull the second, and then it's complete, right? So it's trying to do load balancing. Why I bring this up is I've started to change my best practice to be triggered. So I know exactly what's going on, and then I can move those triggers to cyclical pollers or to events that create reports and things of that nature. So they only really happen once. So that's kind of a best practice that I've kind of leaned towards. And so why the polar page is important to me is if I do have cyclical polars, I can see if I've overloaded the system, right? I've overloaded the queue. If I start to see that my 30-second rate is now 60 seconds, it can't get everything done in that 30 seconds. And so just be aware of that. And so these little buttons that I do here, they're just responsive panes. And so one of the things I'll do is I'll just move those into whatever PX page I'm working on. So if you click on this, it'll just show you it's a responsive pane. And when I'm done with that, I just delete them. But it's a quick way of me to remind myself, oh, refresh that cache because I've moved things around and I've added new tags. Go ahead and execute the poller so I can test my output and then visualize those polar pages so that you can see that. So again, when you look at the best practices for analytics is create a structure and relativize your ords so you can very easily cut, copy, and paste the logic, right, from the wire sheet. I can just copy this, paste it, and as long as I put it in a folder below, it will go to its parent and then execute. So it makes it real easy. I can just drop this in. And this is also nice if you follow this pattern, you can create templates for your analytics and deploy them relatively easy. The other thing is these analytic proxy points I've seen a lot of people that always try to do services, or not service, but analytic alerts, and they struggle with alerts because it's very singular. It says, okay, I found the problem, but it doesn't allow you to do certain things that might be required to do smarter alarms. So analytic proxy points, and I actually have a tips trick on YouTube that walks through this, but I can take that analytic proxy point, add a normal Niagara alarm, and what I can do is in the analytic, I can check for several values before I alarm, right? So I can make things a lot smarter. Tag rules first. This was hard for me to get over because I like to direct tag, but if you do something stupid, like I always do, I can fix it really fast. I don't have to worry about artifacts of my poor tagging. It future proofs so that if, let's say, some other buddy comes up with a better way of applying tags, right, I can add that tag dictionary and then change mine to apply the new standard. So that's really good. And I always like to say my one tag dictionary rules them all, right? It's applying all of those components within the tag dictionary. And then never always remember to refresh your cache. So that's just tagging. When you look at hierarchies, right? So again, when I do a hierarchy, I kind of jump into it, I remember it, and then I walk away from it. So what I want to show you here is we can actually use the hierarchies and the tags in the hierarchies to kind of walk through how to create a hierarchy that's a little easier for me to understand. Now, if you're a Niagara Jedi Master, you know all kinds of things that you can do on looking for relations and things of that nature, and it can be very powerful. So I'm going to start simple because that's the way I am. And so the first hierarchy I'll walk you through is creating a PX view. So essentially, I use that new tag that's available in 410 to find all of the folders that have views attached to them, which is nice because I like to put together, these are the dashboards, right? So if I go to building 1, I see its dashboard. If I go to floor 1, I'm seeing floor 1's dashboard. If I go down in the room, I'm seeing the room's dashboard, right? So those are nice ways of pulling those out and showing them. So if you look at the hierarchy, then let's go over here to the service. When you look at how I created this hierarchy, why is that doing that? So let me fire this up one more time. This was the gremlin in the machine. My machine timed out 3 times while I was watching and learning from Eric. All right, so I'm going to bang back over here. Log back in. All right, so we go back to my services here. So let's go down into the tag dictionary. Was that where I was going? See, okay. So no, I want to go into hierarchies. There we go. So in the hierarchy, then my PX view, right? If we look at this, we can see that I have a simple query, and I can handle queries and hierarchies. So I just go out and say, go find anything that has the implied tag has HXPX view. And so if you go down to the actual hierarchy, you get my PX views and everything with it. So I was like, that is cool. So how else can I use tags then, right? So I started out to say, okay, let's look at creating a campus, right? A view where I do a bunch of queries to find the building, to find the floor, to find the room, and then find this temp, CO2, and humidity tag, right? So I jumped in that, but what happens is the way hierarchies work and the way it traverses the data is this I thought worked great until I come down to the last point, right? And that is if I go to rooms, it duplicates both sets of tags in both rooms, right? It's giving me room 100 and room 101 inside there. So I'm like, oh, darn, yeah, I forgot about that. So, and again, this is one of those things that if you don't use hierarchies, it sometimes bites you. So I went back and said, okay, let's let's go and create a tag. And what is unique about each one of those buildings or each one of those folders is it has a haystack ID, right? So I started to throw that through the query context. And I'm giving you this because I'm showing you how I was not embarrassed, but you go and show it to a Jedi master and they go, well, that was a lot of work when you could just do something better. So I started to do it with context so that I could get the unique values in each of those folders. Well, the queries is great, but I would have to do a context for each level, right? And so that's a lot of work. So if you go down into my next hierarchy, right, is the Jedi masters go, all you have to do really is do a query for the building, right? And you pull up the building and then you can go and say, all right, if the building has that tag, grab it. Then from the rest of them, you're going to do a relation. And remember, Eric was showing you this end child. That is a related tag that gets put on to those parents. So I can look down and say on this relation, look for the child, and it has to have the tag floor and then grab it. And so this actually starts to look very clean. And so this is my new way of tagging, because then as I get to the bottom, I'm already traversed into the appropriate thing. I can just list out what tags I'm looking for. And so if you look at this hierarchy, right, we come down here and not the campus, not quite, but if you come down here into the campus by tags, everything is in its place. So floor 1, room 1, down here, room 101, everything is nice and tidy. So this was very easy for me to understand, right? So when I come back to this, I can look at it and I know exactly what I've done and I can go ahead and apply that, okay? So keep that in mind. If you look at, hold on, one more thing here, go to this one. How I end up going through this is you have to remember what is being applied by your tags, right? With my rules, I've got anything that's inside of my room being tagged by an implied tag. So I have to understand that these are implied and that I know they're there and I can go grab them in my searches, right? It's also nice to know that you can look for direct tags. So anytime anything is run through the analytic engine, it puts an A:A as a direct tag. So I can use that. So if you look at one of my hierarchies that says, just show me all the analytic points, right? The end value is saying, go give me any point that has the direct tag A:A. And so it gets all these other points that I have inside that room. So keep that in mind. Implied tags, I had to use the implied name tag to get the points, right? So I've applied that so that I can get that point folder. And then keep in mind that implied relations will really help you in that quest for creating those hierarchies, okay? So this is kind of, again, I'm going to probably do a Tridium Niagara pro tip on this because it kind of, this week when I forced myself to do this, it was like, oh, this is so much easier if you start thinking it through it that way. So I'll get do some more details on that. And so one last thing, and I know I'm running a little over here, is and in fact, it showed up in a question, I think Jack asked it, and that is, how do I, if I want to use essentially, oops, not this one, I'm going to do cut, copy, and paste. This is the kind of like I have the ingredients all ready to put in the oven. So how do I, use tags to do searches? And so I can do, a HS temp, right? And do a search and I get all the temps. I could say, give me all the B building, right? So searching makes it very easy for the end user to understand these tags, right? And so you can do some pretty cool things with that. One of the things that I did was, how do I take this to a level of, I want to, you get this call where somebody says, hey, the hierarchies are all in one folder and I've got a couple hundred of them. I want them organized by floor. Well, you can do groups, right? History groups, but unfortunately those right now, you have to use string tags. You have to use direct tags that are strings. So what I'm going to do is I'm going to search for all of the config points, right? That are history configs. So now I have them there. And then what I want to do is I want to go into the tag manager And I'm going to take all of those that I found in that search, right? And I'm going to just drag them over into this window, which is this is the tag manager that's new to 410. And so I know that I want to apply to all of them one of my building tags that's just building name, right? Because these are just, I'm going to apply this to only to the tag histories, right? I'm just trying to organize them. So I've got them all there. All of them belong to floor 1. So I know that all of them are going to get the floor 1 tag. So I'm going to drag that down there and we'll just say floor 01. Oops, and it has a slash. Floor 01, right? And then I need to do room 101 separately for room name. So I'll go select those first 3, and these will be room 100. And then I'm going to select these 3, and then I'm going to say room name is room 101. This is kind of like the firework moment, because this made a whole lot of sense to me when I did this. And so now if you go down into the histories and we refresh this, right, you'll see that it's now with those tags. Oh, got the old one. It's now organized those histories per what the customer might have wanted to see, right? So keep that in mind, that you can do this with this tag manager a lot easier than you could with edit tags. Or I'm not very good at the bulk tag editor, right? We have a bulk system that's been there for a legacy. So that's all I have. And again, put your questions into the questions tabs and we'll get those answered.
This is absolutely fantastic. Thank you so much, Kevin. And thanks to everybody who attended today. I'm sorry we've kind of ran out of time at the moment, but we certainly will respond to any questions which we were unable to get to. Just to note a couple things, this demonstration will be posted on Tridium.com under our events tab. So take a look at that when you get a chance. And then in addition to that, as Kevin indicated, we have our Niagara Pro Tips series that we encourage you to take a look at as you are encountering difficulties on the job, or if you're just interested in learning more about Niagara. Thanks again to everyone. Thanks again to Eric and Kevin for joining the call. And I hope everybody has a fantastic day.
Yeah, and just let them know, we will post the video as well as the sample station that Eric and I worked in underneath that in the TridiumTalk posting on our main website. So
Indeed.
People will have access to that station.
Absolutely. And that's going to be incredibly useful for your efforts going forward, especially as you're creating your tag dictionaries or you're evaluating your existing tag dictionaries for its suitability. We think that the station's really going to give you some pointers to help you with your efforts going forward. So as such, thanks again to everyone. I hope everybody has a fantastic Thursday. Take care.